Hello students, in this video I will go through exercise U4A03A, which is applying properties of rectangles. Let's take a look. For question 5, it says if FD is equal to 3x minus 7 and EG is equal to x plus 5, find EG. So I will just label this, or actually I'm going to reference what is that information related to the diagram here. So FD is a diagonal and EG is also a diagonal. What do I know about diagonals in a rectangle? Well, I know that diagonals are supposed to be equal to one another, so therefore I can say FD is equal to EG. So 3x minus 7 will equal to x plus 5. So I can solve for x, subtract x, I get 2x, add 7, I get 12, divide by 2, I get 6. And the question says to find out what EG is. So if x is equal to 6, then that means EG is equal to 11. Then it says find angle EFD if it equals, it's telling us EFD is equal to 2x plus 3, 2x minus 3. So EFD is this guy right here, and that's 2x minus 3. And DFG is this guy right there, and that's x plus 12. And what we know about, and it says to find out what is EFD. Okay, so one of the properties of a rectangle is that it's a parallelogram with at least one right angle, which in this case it does. And if there's one right angle, that means all four angles are going to be right angles. So therefore I can say x plus 12 plus 2x minus 3. Those two angles together should add up to 90 degrees because they make up the whole bottom right corner of that rectangle. So then I can combine like terms to make 3x plus 9 is equal to 90. Subtract 9 from both sides, I get 3x is equal to 81. Divide by 3, I get 27. So since x is equal to 27, then I can then substitute this back in here, and I will end up with 39. And this will be 51. So the answer to EFD is 51. Angle EFD is equal to 51. Alright, question number 14. If ZY is equal to 2x plus 3, ZY is 2x plus 3, and WX is equal to x plus 4, ZY and WX, these have to be congruent because opposite sides of a rectangle are congruent. So therefore I can say 2x plus 3 is equal to x plus 4. So subtract x from both sides, I end up with x. Subtract 3 from both sides, I end up with x is equal to 1. Since x is equal to 1, WX, therefore, will equal to 5. So that's it. Number 15, if PY is equal to 3x minus 5, PY is 3x minus 5, so this guy right here, that's half the diagonal, and WP is the other half. Find ZP. So understand that actually the diagonals bisect one another, and since they bisect one another and the diagonals are all congruent, so therefore we can say that each one of these parts are all going to be equal. So therefore we can say that 2x plus 11 is equal to 3x minus 5. I'm going to subtract 2x from both sides and add 5 to both sides. I therefore end up with x is equal to 16. Since I know that x is equal to 16, all I got to do is just substitute that back in, and I can find out what PY is. So PY is equal to 48 minus 5, which is 43. So if PY is equal to 43, and I know that ZP is equal to PY, therefore this is all equal to 43. Alright, angle ZYW. ZYW is this angle over here. Is equal to 2x minus 7, and WYX is this angle over here. Those two angles together must add up to 90 degrees. 2x minus 7 plus 2x plus 5 should equal to 90 degrees because all four corners of the rectangle should be 90 degrees. 4x minus 2 is equal to 90. Add 2 to both sides. 4x is equal to 92. So therefore, divide by 4, I end up with 23. as x. However, the question is asking for what is ZYW. What is ZYW? So ZYW is going to be 2. Angle ZYW is 2 times 23 minus 7. So this is 46 minus 7. So this is equal to 39. So angle ZYW is equal to 39 degrees. If ZP is equal to 4x minus 9, ZP is 1/2 the diagonal, and PY is equal to 2x plus 5, PY is 2x plus 5, find ZX. So remember, parts of the diagonal, all parts of the diagonal are going to be equal to one another. So therefore we can say 4x minus 9 is equal to 2x plus 5. Solve for x. I end up with 2x is equal to 9 plus 5 is 14. Divide by 2, x is equal to 7. So if I substitute 7 back in, PY will equal to 14 plus 5 is 19. And ZX will equal to 2 times PY, which is equal to 38. If angle XZY is equal to 3x plus 6, angle XZY is equal to 3x plus 6. So XZY is 3x plus 6, and XZW is equal to 5x minus 12. Find YXW. No, find YXZ. Okay, so since XZW and Z and XZY, these two has to add up to, they must add up to 90 degrees. So then this combined together, this is 8x. 6 minus 12 is minus 6. Add 6 to both sides. 8x is equal to 96. Divide by 8, x is equal to 12. Since x is equal to 12, I can then substitute, well, I'm asked to find out what is angle YXZ, right? YXZ, which is this angle over here. YXZ is going to be congruent to this guy, XZW. So therefore, I take 12 and substitute it back into XZW. So angle XZW is equal to 5 times 12 minus 12, or it's really 48. Okay, angle ZXW, ZXW, and WZX, ZXW. So I'm dealing with a triangle here. So I'm dealing with this right triangle, and I'm going to look at this in isolation. So ZXW is this angle, and WZX is this angle. These two angles must be complementary because all three angles add up to 180, and I already have 190 degree angle there. So all I got to do is say x minus 11 plus x minus 9 is equal to 90 degrees. I add negative 11 and negative 9 together, I get negative 20, so I end up with 2x minus 20 is equal to 90. Add 20 to both sides, 2x is equal to 110. Divide by 2, x is equal to 55. Since x is equal to 55, and I'm asked to find out what ZXY is, right? So ZXY is going to be, so it's essentially the same problem as before, right? Looking at this, I'm asked to find out what ZXY is. ZXY is going to be congruent to WZX. So WZX, so angle WZX is equal to angle ZXY. And WZX, therefore, is equal to 55 minus 9, which is 46. So angle ZXY is equal to 46. Okay, moving on. Quadrilateral ABCD is a rectangle. Find each measure if angle 2 is equal to 40 degrees. So if this is 40 degrees, that means this is 50 degrees. And if that is 50 degrees, then that means this is 50 degrees, and that means this is 80 degrees, this is 80, this is 100, this is 100, that means this is 40, 50. It says that this is a rectangle, right? So all of these are going to have these angle measures. So looking at this right now, angle 1, what will that be? That's 50. Angle 7 is 40. Angle 3 is 40. Angle 5 is 80. Angle 6 is 50. And angle 8 is 100. Which really doesn't look it, but it doesn't matter. Nothing's ever drawn to scale anyway. And if things are drawn to scale, that's just meant to help you. But most of the time, these standardized exams, well, I take that back. A lot of times, Regents exams, the diagrams are drawn to scale. But SATs usually is not. Okay, question 39. If XW is equal to 3, XW is equal to 3, and WZ is equal to 4, WZ is equal to 4, and XZ is equal to B, XZ is equal to B, find YW. Okay, so in other words, well, you know, this is a 3, 4, 5 triangle. We know that XZ is equal to 5. Whoops. We know that XZ is equal to 5. WXZ. This is 3, this is 4. This has to be 5 because of the Pythagorean theorem. So if XZ is equal to 5, YW, which is the other diagonal, should also equal to 5. If XZ is equal to 2C, XZ is equal to 2C, ZY is equal to 6, and XY is equal to 8. Find WY. Okay, so XZ is equal to 2C. You know what? I'm just going to draw it like this. ZY is 6. XY is 8. This is, again, a 3, 4, 5 triangle, right? And if you don't recognize being a 3, 4, 5 triangle, you can always do 6 squared plus 8 squared and then square root that. You get 100, which is 10, right? So this is 10. And since that's 10, this is also XZ, right? XZ is equal to 10. You really don't need to know what C is to figure this out. Since XZ is equal to WY, and that's equal to 10, WY is equal to 10. That's all it is. Okay, number 45, rectangle ABCD, EAB. So here we need to actually draw this out. And the way in which we read this, right, everything will always go in either clockwise or counterclockwise orientation. So we can draw it like this, A, B, C, D. And it really doesn't matter whether we draw it clockwise or counterclockwise. Angle EAB is equal to 4x plus 6. So, you know, they didn't say this, then this is bad on their part, but I'm going to assume that E is the intersection of the diagonals here, and it says that angle EAB is equal to 4x plus 6. Okay, and DEC is equal to 10 minus 11y, and EBC is equal to 60. EBC is equal to 60, so that means this angle over here is 60 degrees. Find values of x and y. Okay, so if that's 60, that means this is 60. And EAB DEC is 11 minus, well, since DEC, angle DEC, plus this angle over here must therefore equal to 60 degrees, right? Because all three angles must add up to 180. So DEC plus 60 should equal to 180. Or in other words, DEC is equal to 120 then, right? And since DEC is equal to 120, we can then solve for what y is, since this is equal to 10 minus 11y. If I subtract both sides by 10 and then divide by negative 11, I end up with y is equal to negative 10. So y is equal to negative 10. And then we got to figure out what is x equal to, right? So since DEC is equal to 120, we can now apply that to EAB. So this is going to be 120. Angle EAB, therefore, this must be, how much is that? That must be 30 apiece, right? Because both of these should add up, both of those should be the same, and all three of the angles should add up to 180. 30, 30, and 120 makes 180. So if that's the case, then we can say that angle EAB is also equal to 30 degrees, or 4x plus 6 is equal to 30. So therefore, subtract 6 and divide by 4, x will equal to 6. There you go. Find x and y so that the quadrilateral is a parallelogram. Okay, so we know that 2x plus 7 should equal to 4x, should equal to x plus 9. And subtract x, subtract 7, x is equal to 3. And not only should opposite sides be the same, but also consecutive interior angles should be supplementary. So 2y minus 5 plus 2y plus 21 is equal to 180. Combine like terms, 4y plus 16 should equal to 180. Subtract 16, 4y is equal to 164. Divide by 4, y is equal to 41. Okay, next. We just need to show that, to make this a parallelogram. So, alternate interior angles should be the same. So 3y plus 3 should equal to 4y minus 10. Subtract 3y, add 10, we get y is equal to 13. Opposite side should be the same. 4x minus 17 should equal to 2x minus 1. Subtract 2x, add 17, divide by 2. Alternate interior angles should be the same. So 2x plus 6 is equal to y plus 3. 2y plus 5 is equal to 4y minus 9. And this becomes a system of equations, which I screwed up royally in 2 videos ago. I don't know why I had like brain freeze there, but I'm going to try to do a better job here. So I'm going to bring all the variables over to one side. 2x minus y is equal to negative 3. And, yeah, I can just solve for y in the second equation here. So this is going to be 2, if I subtract 2y, I end up with 2y, and if I add 9, I end up with 14. Therefore, y is equal to 7. And since y is equal to 7, I can then take that and substitute it back up here. I end up with 2x minus 7 is equal to negative 3. Add 7 to both sides. 2x is equal to 4. And divide by 2, x is equal to 2. That's all it is.